Welcome to this video on the Automic Automation Azure Power BI integration solution. In this video, we will explain the Azure Power BI cloud integration and what it brings to the Automic Automation user community. Azure Power BI's core functionality revolves around reporting and data analytics. It allows users to fetch data from various sources, process it, and display it to users. One of its strengths is the ability to refresh datasets. Integrating Automic Automation with Azure Power BI allows you to run Azure Power BI jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating Azure Power BI, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Azure Power BI processes can then be synchronized with all other environments routinely supported by Automic Automation. Azure Power BI's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Azure Power BI environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to Power BI jobs. Automic Automation lets us build configurations with intuitive interfaces like drag and drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation significantly simplifies the configuration and orchestration of Azure Power BI jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values. System, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository, a connection object to store the Azure Power BI endpoint and login data, and a job template designed to trigger Azure Power BI jobs. Let's assume we're automating for 4 instances of Azure Power BI. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the Azure Power BI jobs in Automic Automation for each corresponding process in Azure Power BI. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Azure Power BI. We're able to retrieve the successive statuses and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Azure Power BI integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Azure Power BI is a standard Automic agent. It requires at least 4 values to be updated. Agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Azure Power BI instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Azure Power BI endpoint. Finally, we use the Azure Power BI template jobs to create the jobs we need. We match these Automic automation jobs to the Azure Power BI jobs, reference the connection object, and run them. We're able to supervise the jobs, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Azure Power BI integration. The agent is included in the Azure Power BI package, which we download from Marketplace. We unzip the package, which creates a file system agent/Azure Power BI/bin that contains the agent files. Based on the platform, we rename the agent configuration file UCXJCIDX and set a minimum of 4 values. The agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Azure Power BI job templates. In our demo, we will create a connection object. Once we have established the connection to the Azure Power BI environment, we'll create a refresh dataset job. Finally, we'll execute and supervise this job. Let's explore the Azure Power BI console. This is where you monitor your jobs and interact with your work and datasets. Upon entering the console, you'll immediately notice workspaces. You can see your My Workspace here, and you also have the option to create a new workspace. These workspaces are essential as they house the datasets where your jobs will run. Within a chosen workspace, such as the WLA workspace we've seen, you'll find your datasets. For instance, selecting a specific dataset like WLA dataset allows you to perform actions like refreshing it. Once you initiate a refresh, you can then access the refresh history. The refresh history is crucial for monitoring your jobs. Here, you can see the status of all jobs, whether they are running, completed, or in progress. You'll find important details such as request IDs, start and end times, and other relevant information. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to Azure Power BI. This object is crucial as it establishes the link between Automic and your Power BI environment. The first field you'll see is base URL. This is where you need to provide the endpoint for your Power BI service. Next, we come to the authentication types. We have 3 options: the service principal type, the OAuth2 token type, and the token from file type. If you choose service principal, you will need to provide 3 specific credentials for authentication purposes: the tenant ID, the client ID, and the client secret. For OAuth, you need to specify the OAuth version you are using. This can be version 1 or version 2. If you select version 1, you will need to provide a resource. If you select version 2, you will need to provide a scope. The OAuth2 token authentication type requires you to specify a token The third option is token from file. This is the chosen method for this demo, and it allows you to directly specify a file containing the authentication token. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. And that's how you create and configure a Power BI connection object. This object will then be used to map to your Power BI jobs, allowing Automic to seamlessly interact with your Power BI environment. Once the connection object is defined, you can create a refresh datasets job. The connection drop-down list lets us map a previously created connection object with this particular job. You can create a refresh datasets job. The connection drop-down list lets us map a previously created connection object with this particular job. After selecting the connection, you select the workspace. You can search for the workspace by clicking a picker button, which will list all workspaces related to the connection. For the demo, we use the WLA workspace. Once the workspace is selected, you then select the specific dataset from within that workspace. This is also done by clicking a picker button, which will list all datasets. So let's go to the attributes page of the job, and make sure you select the agent that corresponds to the agent name you configured in the INI file. These configurations are performed after creating the job object and are essential before saving and executing the job. Everything is configured now, so we can execute the job within the AWI portal. The system will then show the job as active in the executions view. Simultaneously, you can switch to the Power BI console. By navigating to the relevant workspace and dataset, and then checking the refresh history, you can monitor the status of the job. Once the job is completed, its status will update in both the Automic AWI portal and the Power BI console. Let's go to the executions view. It shows the list of executions in Automic Automation. As you can see, this is the job we have created and it ended okay. You can then open the report within the AWI portal for that specific job. This report will display details, including a request ID. You can compare this request ID from the Automic report with the request ID shown in the Power BI console's refresh history to confirm that the same job executed successfully. Within the Automic AWI portal, you can also monitor the logs for the executed job. These logs provide information about the input fields and the running logs of the job. That wraps up the demo on how Automic Automation allows you to schedule, execute, and monitor Power BI reports and datasets directly from its interface, ensuring seamless coordination and reducing manual intervention. Thank you for watching this video.